Welcome to vForum Online. My name is Arup Deb. I'm a systems engineer with the Networking and Security Business Unit. So today I'm going to introduce the Virtual Cloud Network and also NSX Software Defined Wan by Velocloud. So if we think about the Virtual Cloud Network, what makes this up? I'll explain it as three main pillars. The first one is that it's a single fabric. So one fabric to connect to different type of endpoints and workloads. The second point is that it's highly automated and it's all in software. So we'll note this down as all in software. The third point is that it's intrinsically secure. I'll touch on each of these 3 points now. So when I mean one fabric, well, you're probably already familiar with VMware virtualizing the networking in the data center. We do this with NSX for data center. But what you may not have seen yet is that we're actually extending this out to public clouds where we can host either VMs, we can also do container networking and security, we can also do users. So we're giving you one fabric that covers all different types of workloads and endpoints. And how about highly automated and in software? What do we mean by this? What we mean is that in the highly dynamic workloads that we have today, which are containers and VMs, when you're spinning up and down workloads, you don't want to have to manually configure security and networking policies on things like hardware appliances, which are routers, switches, and firewalls. In these dynamic environments, we need to automate that process so the network can actually keep up with the speed of our workloads. And third of all, security. In terms of security, we don't wish to have workloads coming on and off the network and having to manually secure them. What we want is that the security policy to live very close to the workload. So if you're expanding your cluster of web servers, then we already know that the new web servers need a particular policy, and this happens automatically. And that's the three main pillars of the virtual cloud network. So to add to this, you might be wondering, well, what's a practical example? A practical example would be this. Say we think about an application that we're using on a daily basis, which is perhaps a payment app. If we open our mobile phone, load up the payment application, perhaps the front end is sitting on public cloud. But when you actually log in, that user database that has your identity may be sitting on a virtual machine in a private data center. And third of all, when you actually try and make a payment, this might leverage a bank system, which might be a mainframe. So even though from the user perspective, it's quite straightforward. We open our app, we log in, we make a payment. But this app is reaching out to the public cloud, a virtual machine in your own data center, and perhaps a physical mainframe system. So the networking and security that happens behind the scenes is quite complex, and we definitely cannot achieve that with a hardware-based traditional approach. So one of the cool things we can do today is to actually extend this virtual cloud network out to branches. So not only can we do on-prem, public cloud, we can also extend this out to branches. And you might be thinking, well, why do we need to extend it out to branches? If you've walked into any modern bank, you'll see that people inside are probably using voice over IP phones. They're probably making some video calls on maybe iPads to personal bankers or to customers. And the people working in the branch are probably using some SaaS applications, maybe for Office, maybe for HR, whatever it may be. So the type of services that we're using in the branch today are quite advanced, and actually the network is critical for them to work. So what are the three main points that we achieve with Velocloud? First of all, it's management. So it's how we're able to manage our wide area network. Second, it's performance. We need to ensure the performance of these modern applications that we're using in our branches. And third, we want to provide an on-ramp to the cloud. So if you're using cloud apps from the branch, something like our Office or messaging apps, which are actually sitting on public cloud, we want to provide an effective on-ramp to the cloud. So let's talk about management first. If we have a traditional branch network, we'll have, say, a router sitting in each branch. This router has a console. It needs to be managed individually. So say you have a branch network of 1,000 endpoints. Then you have 1,000 individual endpoints to manage. it becomes a nightmare. There's no single point where you can take care of this. So what's the solution that we have? We have something called the Velocloud Orchestrator. So this Velocloud Orchestrator is a cloud-based software where from one point, so it's a single GUI, you can manage either one branch or 2,000 branches. And you can do it in a very nice, repeatable, and automated fashion. So one of the use cases that I'll share that we can achieve with the Orchestrator is to onboard a new branch. So say you go ahead and deploy a new branch and you wish it to join the rest of your WAN network. It's actually quite straightforward with VeloCloud. Instead of having somebody go out with a physical router and manually put in the configuration and test that it works, instead of that, what we do is that we have a device called a VeloCloud Edge, which is just a x86 appliance. It can also be a virtual machine, but in our example, we'll say that this is actually just an appliance. So we ship out an appliance, and then someone at the branch, and they don't need to be an IT expert, they're able to actually connect this guy to the internet. The second step is they check their email. So from the Orchestrator, we're able to send this person an email. All they need to do is open up the email. Then the edge device will pull down the configuration from the Orchestrator and join the rest of the WAN network. So that's how we can make management of our software-defined WAN network very simple, and we can onboard and turn off branches very easily. So in terms of performance, if we think about how we do branch networking traditionally between our branch and our data center, you might have a private circuit, so something like an MPLS circuit that's provided from your service provider. There's a couple of issues with this. One is cost. There's an ongoing subscription cost to this, quite high. The other thing is performance. Performance may not be as good as you expect. And also they can take quite a long time to deploy. You might take 4 to 8 weeks to deploy this private link. So we solve the first problem by giving you choice. You're able to not only use, say, a private circuit from a provider, you're able to use public internet. You may also be able to use something like a 4G connection, so a LTE modem you just plug into your edge. So we give you choice of connectivity. You can save cost and you can bring up a connection very easily, as simple as plugging in the internet to this box or plugging in LTE modem into this box. That's one way we solve it. In terms of our application performance, the way we solve this is with some technology called DMPO. We can summarize this as 3 main points. So the first thing that we do with DMPO is monitoring. The second point we do is per packet link steering. And the third point is remediation. So I'll deep dive into each of these 3 points a little bit. So in terms of monitoring, what do we mean? So we check the bandwidth of these links. We know if they're up or down. We check for things like latency, jitter, and packet loss. So if anything goes wrong on these links, we definitely know about it so we can make the most informed decision about our traffic. And that brings me to per packet link steering. What this does is that our edge device sitting at the branch is able to identify all the application traffic that's coming in. So our edge device knows about whether there's voice traffic, video traffic, or just someone browsing the internet. And so with a combination of the information about the links and the application, based on that, we're able to use the best link, most appropriate for the traffic. And now the third point, remediation. So say you have a traditional branch network with a router sitting at the branch. If you have a voice over IP call and one of these links starts to go down, then you can't do much. The voice traffic will go bad and the call will most likely drop. The way we do it is that mid-call, even if the link that you're using starts to degrade, we're actually able to send that traffic onto a good link. So from the user perspective, the voice quality remains high and actually the call will not drop. So nothing is noticed from the user perspective, even if you have a link going down or sudden packet loss. And that applies to all the traffic in the branch. So in the end, the user experience is far improved. It's consistent and much faster. That's how we take care of performance. So how about on-ramp to the cloud? I'll give you an example. So say you have some users in a branch and they wish to access Office 365. So Office 365 is a cloud-based SaaS application, or it could be any type of other SaaS up here. So traditionally, well, we have the internet, and users at the branch, you'd think that, well, why don't we directly access our Office 365 over the internet? The problem with that is that you don't have any visibility or control over this link to the internet onto your SaaS applications. So it's not practical for most enterprises to allow this. So what most enterprises do is, instead of that, they'll take the long way around. What this means is that first, from the branch, you need to access the data center. Then from the data center, we have a secure internet link, and that's how we access our Office 365 or SaaS. So it's a long way around, and we call that backhauling. So you can imagine, with modern enterprise applications in your data center, with things like voice and video all traversing this WAN link, we can easily saturate the link and have some performance issues just to try and access our SaaS applications up here. It doesn't make a lot of sense. So instead of that, we do have a solution. So we have something called the Velocloud Cloud Gateways. So the Cloud Gateway is a gateway device that is sitting very close to these SaaS applications. So they're sitting in public cloud data centers, and they give you close access to things like any of the SaaS running inside of there. And what we do is, just like before, I explained that we have an edge device at each branch. So our Velocloud edge device makes a secure tunnel to this cloud gateway. And so through that secure tunnel, we are able to access our SaaS applications. And so by doing this, instead of backhauling the traffic the long way, it's a much faster access, and you gain back things such as visibility, control, performance, and most importantly, this link, this on-ramp to your cloud applications becomes part of your single fabric and part of your virtual cloud network. So as a summary, your virtual cloud network extends not only from your data center, not only to containers, VMs, and public cloud workloads, but also users and even branch networking, including the links up to SaaS. Thank you very much for watching vForum Online. I hope you enjoyed the session.